Alright, so now let's have a look at the 4 electron group. Let's start with the 4 bonding pairs. So the general formula for 4 bonding pairs is AX4. Okay, so the electron group arrangement is tetrahedral and the molecular shape is also tetrahedral. So let's have a look at the example for the 3D AX4. Right, so this is how the AX4 looks like. Okay, so all the bond angle, okay, is 109.5 degree. It is the same, right? So if you uh, spin it like this, okay, you can see that the shape is still the same. Okay, the bond angle is still the same. It does not change. So to draw the tetrahedral in 2D, okay, so we start off with the central atom, and then we have 1 bonding, 2 bonding, 3 bonding, and 4 bonding. And then put the bond angle, okay, 109.5 degree. So due to the repulsion between bonding pairs are equal, so that's why we got the same bond angle here. So now let's have a look at NH₄ plus, okay, the example for 4 bonding pairs, okay. So first, as usual, calculate the total number of valence electron. So we have 8 total number of valence electron, okay, so nitrogen will become the central atom, okay, because hydrogen is duplet, okay, 1, 2, 3, 4, okay, so the formal charge, okay, for each atom is 0, 0, 0, and 0. But then for nitrogen, 5 minus 4, it is positive 1. So the positive 1 in NH4 actually is on the nitrogen. So if you already put the formal charge, okay, on the atoms, okay, there is no need to put the bracket. Okay, tak perlu dah letak bracket lagi sebab kita dah letak dia punya charge dekat sini. Tapi kalau you nak letak juga dia punya bracket pun tak ada masalah. Okay, you boleh letak juga the bracket. Tak ada masalah. Alright. So to draw the molecular shape, okay, we put the central atom. Okay, and then 1 hydrogen, 2, 3, and 4. Okay, and then we have the bond angle 109.5 degrees. Okay, so since the nitrogen here is the positive charge, okay, we put positive charge on the nitrogen. Okay, so you nak buat macam ni pun boleh ataupun kalau tak nak buat macam ni, nak guna bracket juga pun tak ada masalah. Okay. So next, let's have a look at the 3 bonding pairs and 1 lone pair still in 4 electron group. So the general formula is AX3E. Okay, so we have 1 lone pair here. Okay, the electron group arrangement is still tetrahedral, but then the molecular shape now is changed into trigonal pyramidal. So let's have a look at the 3D structure. Just now we have the tetrahedral, so now I'm going to move one of the bond and then replace it with the lone pair. Okay, so we have 3 bonding pairs and 1 lone pair. So if you can see here, okay, we have a pyramid, okay, with 3 legs. Okay, that's why the molecular shape is trigonal pyramidal. So in 2D, okay, so put the central atom. Okay, just now in tetrahedral we got the 1 bonding here, but now I'm going to replace it with the lone pair. Okay, so since the repulsion between lone pairs bonding pairs are greater than bonding pairs, okay, just now we have 109.5 degree. Now it will become less than 109.5 degree. Or, okay, for ammonia, okay, ammonia, you have to memorize the bond angle for ammonia, 107.3 degree. Okay, less than 109.5 degree. So ammonia got trigonal pyramidal shape. Okay, let's see how ammonia got the trigonal pyramidal shape. Okay, so the Lewis structure. So nitrogen gonna become our central atom, and then we have 3 hydrogen. Okay, so 8 minus 6 electron. Okay, we have 2 electron left, so the 2 electron will be put on the nitrogen. Okay, so nitrogen is hot, hydrogen is the black. Okay, so the formal charge 0, 0, 0, and 0. So to draw it in 2D, okay, nitrogen, hydrogen, hydrogen, and hydrogen, and then we have a lone pair here. And then remember, the bond angle for the nitrogen is 107.3 degree due to the repulsion between lone pairs bonding pairs are greater than bonding pairs. Okay, last but not least, in 4 electron group, we have 2 bonding pairs and 2 lone pairs. So the general formula is NH₃ Okay, so the electron group arrangement is still tetrahedral, but then the shape are going to be the V shape. So we have tetrahedral here with 4 bonding pairs. Now I'm gonna remove 2 of the bonding and then replace it with 2 lone pairs. So as you can see here, the shape now become a V shape or bend. Okay. So to draw it in 2D, right? So just put 2 bonding here, and then we have 2 lone pairs surrounding the central atom. So due to the lone pairs repulsion are greater than lone pairs bonding pair repulsion, greater than bonding pairs repulsion. Okay, so now again the bond angle will become less than 109.5 degree, obviously, but then to see it better, okay, so we have the bond angle for water molecule that you need to memorize is 104.5 degrees, so it is smaller than ammonia. So water got the V shape. So the total number of valence electron in water is 8 electrons. So we have the oxygen on the central, okay, and then 2 hydrogen bonded to the oxygen. So we already used 4 electrons, okay. So there is 4 electron left. We are going to put it on the oxygen. Okay, so this is the Lewis structure for water, okay, where hydrogen got 0 formal charge, oxygen also got 0 formal charge. Okay, so here we can see that the water molecules got 2 bonding pairs, okay, and also 2 lone pairs. Okay, so the electron group is for 2 bonding pairs and 2 lone pairs. So the arrangement is still tetrahedral, but then the shape is going to be the V shape. So to draw it in 2D, okay, we put the central atom first, and then the surrounding atoms, okay, and then the 2 lone pairs we are going to put it side by side. Okay, and then the bond angle, if you remember, the bond angle for water is 104.5 degree. It is smaller than ammonia, 3 bonding pairs and 1 lone pair.